Okay, so the objective for our lesson right now will be about arrays. But before I get into that, let's look at memory like this. So let's say we have a large building, really tall, and it has stories. Each one of these stories is a single byte of memory. So that means each one of these stories is an addressable location that you can access, or the system will allow you to access it when you declare a variable, right, of any form. So let's say in your code you said something like this, int a semicolon. So what it means is that somewhere in the addressable space in memory, now remember, an integer takes 4 bytes, right? So you're going to get 4 bytes automatically, or 1, 2, 3, 4 automatic bytes reserved for the variable a. Okay? Now, however, the address of a is going to be the lowest one right here. So end of a will be the address of this particular byte. And then you're going to count 1, 2, 3, 4 bytes to store, for example, let's say a equal -1. To store the value -1, it will take all of these 4 bytes to store that value. Okay? Now let's say you do an int b now. Well, you're given another 4 bytes, right? So starting at some address where %b is here, which means automatically you have a reserved 4 bytes. So you have 1, 2, 3, 4, 4b. Okay? And if you say b equal 20, well, then 20 will be stored within those 4 bytes. Here's the thing. You had no control over the assignment of these addresses, other than the space where they were, by declaring them either local, global, what have you. Okay? And which means if you were to step based on the addresses, and you wanted to go from A to B based on addresses, you're going to have a problem because you have some gap here. You don't know what's the difference in bytes between them. So really, you can't use it for a data structure, for example, where data might be stored in consecutive locations, like something like a stack or a queue, right? Something like this, where my data, so I have data 1, data 2. These could be integers, they could be floats, as long as they're the same type. So this container right here will have these data. Now, if I know the address of the first one, then it's very easy to know the address of the second one and the third one. Then I can write an algorithm or code to step through the data either this way or that way. Okay? Since I will know the head of the data and the tail of the data, I'll have delineator that expresses that. It's much easier in terms of managing data. Here, what I have is 2 independent variables, a and b, right? So this is b and this is a, and they're totally independent. So there's no structure that says how to move from a to b, either through assignments or by reading specifically a or specifically b, or by using a pointer that points to A and then will point to B. Okay? Wouldn't it be nice to have a different kind of access or a mode of access? And the answer is yes. So let me just get my mouse going here and clear the screen here and show you what else can be done. Now, let's look at memory again. And let's say we have these bytes going on like this. Okay? What if 1, 2, 3, 4, I can reserve this, then the one next to it, 1, 2, 3, 4. Then the next one to it, 1, 2, 3, 4. In one data structure. Right? So we're talking about some sort of a data structure that allows me to have all of this named one thing, and then I can access these ones individually to store integers. Now I picked 4 bytes since I want to contain integers in it. So in other words, what I'm creating is an array that will contain data 1 of type integer, data 2, data 3, and data 4. So 4 elements in memory in here, right? So this would be D4, what is it? Oh, I have more. So 1, 2, 3, 4. So maybe this, okay? So D4 here, D3 here, D2 here, and D1 here, right? So how would I write the code for something like this? And well, simply remember when, let's say if each one is going to hold 4 bytes, so that means it contains integers in them. So you definitely will need to start with the keyword int. And then call it whatever the variable is. So this whole thing will have a name, okay? And that will be the name of the array that you want. So remember, we're doing now arrays, okay? So this special data structure is called an array. So we're going to call it, let's say, AR for array. But then you're going to have to do a bracket here to give it a size. 4. I want 4 elements. Okay? Now the beauty about this is now we can predict where the next element is. Okay? So 4 here is the size of the array. This here is the name of the array. And this here will be the type of the array. Now, how do we access this array? Well, it's going to have 4 elements. And here's the first element, AR, oops, not A5. So the name of the array, you always refer to the name of the array, AR0. Now this 0 here becomes what we call an index. Okay? So here it was called size, now it's called index as I access it. So AR1, AR2, AR3. So it's going to go from 0 to 3, and you have 4 elements. So you always start with index 0. Okay? And you end with index 3, which is size minus 1. Okay? So you always start at 0, you end up with size minus 1. So if size is 4, then your last index is 3. So this is how you refer to each one of these elements. So instead of saying D1, D2, D3, D4, which is too abstract, then the first element here will be called AR0. This one will be AR1. This one here will be AR2. And the last one is AR3. Okay? Let's see this in code. So let me just go ahead and minimize this and go to our code. Okay? And we're going to declare an array as a local variable within our program that will hold 4 elements and 4 integer elements. So int AR, and then put the bracket, put the size, and then put a semicolon. That's it. That's how you declare an array. Can we assign values to it? Yes, you could go to AR0, the index, and then give it a value, 7. And then you can go to AR1, the next element, oops, close the brace this way, and then give it a value of -2, for example. And then can I go to the next one? Sure. AR2 equals -3. 5. Now remember, these are integers, so you can't do a decimal point. Whole numbers. And then lastly is AR3. Remember, it ends at 3, not at 4, since you started at 0. And let's make this one 10. So this is how you typically assign values to these locations. So each one will take 4 bytes. Okay? Now, can we read them to the screen? Can we actually put them out? Okay? Can we print? Let me print the better here. And the answer is yes, you could do printf. And you basically %d, we could see the first element, or you could call it, if you want, you could say something like this, AR0 equals, okay? And then %d, and give me a new line, and AR0. So this is how, oops, 0, not O, right here. I want to know what is the value stored in the AR0, and that will come, since it's an integer, it will be put in this placeholder. Here, you could have said element 0 if you want, okay, instead of AR0. So I'm just writing it up this way, formalize it. How about the next ones? Well, let me just copy and paste this code here. In the future, we're going to learn how to do this in loop. So, because it's kind of the same code, and we're just going to change. So we've got 4 elements. So I'm going to write down, this is AR1, this is AR2, and this would be AR3, right? 4 element total. But make sure that you balance it out this way, because you're referring to element 1, element 0, element 1, element 2, and element 3. So now let's see how this behaves. So let's compile and run. And there you have it. Okay? So it will retrieve 7, -2, -5, and 10. Now, in our next lesson, we're going to see and prove that these elements are located next to each other.